Well, friends, welcome back to this continuation class on multivariate data analysis, and we are actually looking into the different multivariate data analysis techniques that are available. And this is an overview. Basically, we are describing the purpose of different multivariate statistical techniques. We are not going into the details of the computation, but just try to understand why the different statistical tools of multivariate data analysis are used. So we actually come back here and we see that there are now whether there are dependent variables. If there are no dependent variables, what all things we had seen in the previous class, like principal component analysis, factor analysis, cluster analysis, and multidimensional scaling. But if there are dependent variables are there in the system, the next question comes: how many dependent variables are there? Are the dependent variables more than one? If the answer to this is yes, then we have a next question, that whether these more than one dependent variables are metric variables. Metric variables means those variables which are continuous type. That means those variables which are measurable, like we say have measurable things like height, weight, distance, blood pressure, blood sugar. All these things are measurable type of variables. So whether these several dependent variables that we have, are these measurable? Now, if the answer to that question is also yes, then we proceed and we have another question, and that is whether the independent variables are metric variables. So, if your dependent variables are there, then you have to face three questions. How many dependent variables are there? More than one. In the dependent variables are metric variables, and then whether the independent variables are metric. Now, this question comes. If both dependent and independent variables are metric variables and dependent variables are more than one, then we have the next step, and that is the canonical correlation. In such cases, that when we encounter all these answers, and you see in all the answers in the left side are coming out to be, sorry, in the left side of the screen is coming out to be yes, yes, and yes, and then we have canonical correlation. Now let us try to understand what is canonical correlation. So we come here, we have canonical correlation here. This is a method which helps us to identify and quantify the association between two sets of variables. Here one set of variable is the dependent variable, and another set of the variables are the independent variables, and we actually try to find out the correlation between these two sets by linearly combining the dependent variable and the independent variable. So their linear combinations will be compared through correlations, and then we try to find out that particular linear combination which has maximum correlation. Once this is done, that means first set of correlation, first set of canonical correlations are identified. Then we go to the second set of variables. Second set of variables means second set of linear combination of the dependent variable and that of the independent variables. These linear combination are called as canonical variates. So we have first canonical variate, that is pair of combinations of the dependent variable, independent variable. Then another pair of combination of the dependent variable, independent variable, that is called as the second canonical variates. And we search for another pair of canonical variates from both sets of variables that has maximum correlation but uncorrelated with the initially selected pair. So this is the second set, another set of canonical variates. The number of canonical variates pairs identified shall be equal to the number of variables of the smaller set. So that means when we classify the dependent variables and the independent variables, maybe that we have 3 dependent variables and 7 independent variables. So number of canonical variates that will be identified will be equal to the smaller number of set of variables. That is 3 dependent variables and 7 independent variables. So we have 3 canonical pairs. But in general, all canonical pairs may not be statistically significant. So we'll retain in the study only those canonical combinations that are statistically significant. For example, here we have a very nice example. A researcher collects information of 600 school-going students at lower level, and also have collected some information about some psychological variables like locus of seed, self-concept, and motivation. So these are the dependent variables, and then some academic variables by like reading ability, writing ability, maths, and science. So how much they score in these four departments. So that those are the independent variables, and we want to find out that what is the relationship between the dependent variable and independent variable to a linear combination. So when we perform this first linear canonical correlation, I will get two such sets. You see, this is the first set which involves the dependent variables, that is locus of C, self-concept and motivation. Here is the reading, writing, mathematics and science, these four variables. So this is the first linear combination. What is the first linear combination? The first linear combination is this 1.2538 into locus of C minus 0.3513 into self-concept plus 1.2624 into motivation. So this is that. And then we have this set, that is 0.0446 into reading ability, 0.0359 into writing ability, plus 0.0234 into maths, plus 0.005 into science. So this is the another combination that we have. So this is the combination, and the correlation between this left hand side, that means this set with the other set, that means the other one in the that you see in the right side, that canonical variation is coming out to be 0.4641, and these you can see the highest canonical correlation. Other canonical correlations can also be established, like we can have these other canonical correlations, like we can have this set of values, this set of linear relationship, this one with this one. So I can have these into locus of C minus these into self-concept plus these into motivation, then this minus this into reading ability plus this into writing ability plus this into maths minus this into science. So I can have somewhat like this similar type but a different combination. But the canonical correlation of that correlation between those two pairs is this. So this might not be significant, this one and the third one, but this seems to be significant. That means we can retain here only this linear combination. So this is how the canonical correlation is utilized. And so now we can analyze a group of dependent variables with a group of independent variables. So now let us have this. Okay, so this is about canonical correlation. Now, if the independent variables are metric variables, no. If the answer to this question is no, that means the independent variables are dependent variables are many, but independent variables are not metric. Rather, they are categorical variables. Then we can have the MANOVA. Now, what we'll have in MANOVA, this MANOVA concept, it is multivariate analysis of variance. That means here I have many dependent variables. I will say I have dependent variables like I have variables. I have variables x1, I have variables x2, I have variables x3, and all of them are dependent variables. But they are classified into some groups. Suppose I have a group G1 who are having these variables. Then I have another group G2 who are also having values from x1, x2, and x3. Then I have another variable, say a group say G3 who are having variables like x1, x2, x3, like this. Now I want to compare G1, G2, G3. Now I want to compare their averages. That means here there are many people, not only one group, means there are many people here. So 1, 2, 3, 4. So 4 people. Here I may have 7 people. So I may have 7 people. So accordingly for these people there will be 7 observations under each variable. Here there will be 4 observations under each variable. Here suppose there are 6 values. So 6 people are there. 6 people are there. So 6 people are there. So I have 6 values under each variable. Now I have this group means, that means I have from this x1 I get, say the mean, say I get mu1, I get mu2 here for this group, and for this variable, and for the third variable we get mu3. Okay. Now I want to compare whether this is equal to, say this one average, this average is alpha 1, this average is alpha 2, this average is alpha 3. And I have another, say I have another beta 1, beta 2, beta 3 for the third group. Now I want to compare whether all of them are equal. This is equal to, equal means this is equal to this and equal to this is equal to this and equal to this is equal to this, and they are all equal. Now this is the purpose of MANOVA. This is what we are going to test with the help of MANOVA. And if it fails, then we say that no, the group averages are varying. That means on an aggregate, all the values, all the variables taken together, they are not giving the same result. I have some excellent example here. Say IPL is going on now. Now these are the bowling averages, say bowling averages, economy rate. This is the bowling average. This is the economy rate, and this is the strike rate of all foreign spinners. Not only Rashid Khan, but I am taking all the foreign spinners who are playing in IPL. Their batting average, bowling average, economy rate, and strike rate. All the Indian spinners who are playing in the IPL, I am taking their bowling average, their economy rate, and strike rate. So this is the average across all the bowlers, Indian spinners. I mean, here all foreign pacers. Their bowling average, economy rate, strike rate. I have taken the average across all the foreign bowlers, and similarly Indian fast bowlers. These are all foreign pace bowlers. These are all Indian pace bowlers, like that. The numbers may vary because obviously foreign fast bowlers will be less than Indian fast bowlers, and so in case of spinners also. Now what happens in MANOVA, then I can compare whether the this set of averages is equal to this set, is equal to this set, is equal to this set. If this is my null hypothesis. If the hypothesis fails, that means one of them, at least one of the groups are doing better than the other. So one of the groups is performing less than the other. So this is how a MANOVA is actually purpose of MANOVA. Okay. Now let us go back to the main slide where we have all this different descriptions. Okay, sorry, it has gone too far. I come back to this slide. So we were here, we had done this. Now let us look at if the dependent variables are not metric variables. More than one dependent variable but not metric variable. Then what we do is called conjoint analysis. Now conjoint analysis is a very, very important type of analysis for business researchers. The conjoint analysis, basically the purpose of conjoint analysis is used to determine a new product. Now, whenever you look at a new product, maybe an electric equipment, maybe an electronic gadget, maybe a particular financial product like maybe a insurance product, etc. There are different parameters on which actually, or which we call as attributes, or which we call as different types of say parameters on which we choose the product. Like maybe price of the product, design of the product, luminous intensity of the product, color of the product, if it is a television, then sound quality, then connectivity, etc. Many things are there. Now, which combination at what price should be offered by a company so that the product stands nicely, or means product can position itself in the market better than its competitors. So in this case, what the company will do is that company will find out whatever the viable combinations are there, along with the price. Your price is a very important factor. What are the viable combinations that for this price I can offer this combination? For this price I can offer this combination, like that. That yeah, if the price of the phone is 15,000, then I can give 128 GB memory space and 16 GB RAM. But if the price of the phone is 12,000, then I have to make some compromise. I will give 16 GB RAM, but in that case I will have to give 64 MB, 64 GB memory space. 16 GB RAM, 64 GB memory space. Because the price of the phone is less than 12,000. So like this product will make, company will find out different combinations which they can offer, and then all these possible combinations they will make some model, say cell phones, and offer it to some respondents for comparison and reporting. So I get all the, say the company has made 3 possible combinations or 5 possible combinations of phone, and they give it to me. So I will use these phones, and then I will report to the company by ranking them. That okay, this is like rank 1, this is rank 3, this is rank 2, like this I will give the company. And the company will collect data from large number of people. When this data will analyze, they will find out ultimately that which combination is going to stand tall in the market. And they will go ahead with that particular combination and launch the product in the market. So this is how the components are to be combined, different components, so that the product looks nice, product looks The different combination of these components are then studied to identify customer preferences using utility function and econometric models. So there is this is calculations comes through econometric models and application of econometrics. I have an example for you. Now you see I have brand you forget I have three combinations of phones. That means 5-inch screen, color of the phone is silver and price is $1,200. And then this is 6-inch phone, turquoise is the color, $1,100, and 5.5-inch phone, white colored phone, and it has $1,000. These are three phones. And then what I do is that I perform conjoint analysis after collecting information from lot of people. All these people will be given all the three combinations of phone to use and then to rank them. So based on the report that they do, we can perform into this conjoint analysis, and then based on the report that they give, the product concept or the product combination will be decided. That yes, out of these three possible combination, we will go with the second one because second one is mostly preferred by people. So, but there are some utility functions which are being used in the background. This is just to keep the things very simply, and this is information is later utilized to determine the feature of a new product or the customer sensitivity to different attributes. We can understand that which product is which particular attribute out of the 3 or 5 or 7 attributes they use, all of them may not be equally sensitive. That means if the other features like RAM or memory space are good enough, then person may compromise with the color also. They may purchase a P form. It doesn't matter. So these type of interesting decisions or interesting way of understanding consumer behavior comes through the hand of conjoint analysis. Okay, we go back to the side. Now let us see what is if the dependent variable is only one, then what type of analysis is there. But before that, another question pops up, that whether the only single dependent variable that you have, whether that is a metric variable. I told you earlier that metric variable means is the variable measurable or not. Like is the variable something measurable, then this dependent variable is a metric variable. Now, yes, it is measurable. Then we go forward. Now the question is whether the independent variable is a metric variable. If both the question to the answer is yes, then we have multiple regression. And multiple regression is a very common multivariate data analysis technique. Here we have one dependent variable and we have several independent variables. And the basic purpose is to predict the value of the dependent variable when the values of the independent variables are known. Even then, let us have an example here. What is going on here? Okay. Then here we have a dependent variable y, and we have several independent variables which are identified by x1, x2, etc. And we want to predict the value of the dependent variable for a given set of values of the independent variables. That means we have a data set. Data set will have several values of y and several values under x1, x2, etc. Or we want to find out which are the variables that have a significant role on the dependent variable. So this is the equation that we have, and this is the constant of regression, and beta 1, beta 2 dot dot beta k are the partial regression coefficients which are associated with the k dependent variables. So this is the situation in which we are. Epsilon is the residual of regression, and a customer, so we take up an example of this. So this is the regression equation, so these things are explained to you. Now let us look at an example to understand the multiple regression. A consumer product company wants to study the effectiveness of different types of advertising media in promotion of their product. So they are promoting the product using different channels of advertisement, and these channels are radio advertisement, newspaper advertisement, and street side hoardings. So these three advertisements are there, and data is collected from 22 cities for a study period of 1 month. So we go to 22 cities, and from there we collect a data set. Amount of the product sold from the particular shop, that is measured in $1,000, and that is the only dependent variable in our case. And we have data related to sale, means how much money was spent on advertisement in radio, how much was spent in advertisement in newspaper, how much was spent in street side hoardings. all of them are measured in $1,000. So accordingly, what we'll find a relationship of the dependent variable y, that is the amount of sale of the product, with the uh, advertisement in radio, expenditure for newspaper, and expenditure for street side hoardings. This will help us to understand that out of the three channels of advertisement, which channel is more effective and which channel is having a significant impact, and by how much is the impact. So that thing can be studied with the help of multiple regression, and so we can go ahead next year. If all of them are significant, it means that we have to use all the channels. But if one of them comes out to be insignificant, like radio may come out to be insignificant, that means there is no point advertising in radio, because even if we change our expenditure in radio advertisement, this is not affecting the sale much, so radio advertisement can be dropped. But these days, because of FM, and most people who are driving a car, or means going from one place to another by a car, they actually watch, listen to this radio, because listening can be done, watching cannot be done while you drive a car. So accordingly, people get all these things through radio advertisement, so might not be least important also. Now, if the question, if the independent variables are not metric variables, only one dependent variable, that is a metric variable, but independent variables are not metric variable, then we can have multiple ANOVA. That means multivariate regression we can have. A dependent variable is metric, independent variables is not a metric. So multiple regression we have already seen. This multiple regression, can we have a different example? Okay, we have a different example here. So here the independent variable are non-metric type of variable, but the metric, this is continuous, like percentage of marks and hours of study per day and gender. So here you see independent variable are dependent variable is percentage of marks, which is continuous data, and average hours of study per day, this is continuous, but this is categorical, gender. So we have both the types of variables, independent variables. One is a continuous metric type of independent variable, one is non-metric but categorical type of independent variable. In that case, we have a percentage of marks, that means here we may call it y, equal to beta naught plus beta 1, this is x1, which is average hours of studies, and beta 2 into gender x2. So x2 will be coded as say 0 for female and 1 for male. So accordingly, we'll have this is the so this percentage of marks is a function of two variables, average hours of study and gender. And so this you can have like branch of engineering, different branch, that can be another variable. So these are example, like we can have agriculture, electronics and information technology, three branches of engineering, and perform this computation for this. So this is the way you can handle it. Now let us look at ANOVA ANOVA. When we are using ANOVA ANOVA, when there is only one dependent variable, and the independent variables are not metric variables. That means independent variables are there, many independent variables are there, but maybe one also, maybe more than one, maybe 2, 3 independent variables are there, but none of the independent variables hold any numerical value. Rather, they have some categories. So we go with ANOVA ANOVA, and we have the response variable, dependent variable, which is continuous type, but the responses variable are here. In this case, we have taken different experimental conditions. Let us see what are the experimental conditions are there. The variance of the response variable is assumed to be due to different levels of the independent variable. That means independent variables are at different levels. Different levels means different types of maybe categories are there. So different categories are called as different levels, which might influence the dependent variable, or we at least think that the influence of the dependent variable, the dependent variable is influenced by the different levels or different categories of the independent variables, and that leads to an n-way ANOVA with more than two categories are there, more than two independent variables are there, for which classification can be done. Then it is called as an n-way ANOVA. It is 2, then it is called a two-way ANOVA. If it is 1, then it will be called as a one-way ANOVA. Only one independent variable, then one-way ANOVA. Only two independent variable, two-way ANOVA, but more than two. It can also tell us if the interaction of the independent variables influence the response variable. So we have a look at this. So we have an example also here. That example will make the thing clear. So we are doing a field experiment and we are interested in the yield of the crop. So I have separated my field into different plots, and in each plot I have the record of the yield of the crop, that is the numerical variable, continuous type of variable. But I have three independent variables. Let us have them here. So these independent variables are: number one is fertilizer used. Which fertilizer is used? Is potassium used? Is nitrogen used? Is phosphorus used? That is the fertilizer used. Quantity of water irrigated. How much is the quantity of water irrigated? It is 100 liters, it is 200 liters, it is 250 liters, or it is 300 liters. So that is the amount of water that we are using. So we have four categories, and we have tillage of the soil like plowing, harrowing, rotorating, and rolling. So these are the four tillage of the soils that are available. So all these dependent variables are categorical variables. Only the dependent variable, all these independent variables are categorical variables. Dependent variable yield is yield of the crop is dependent. So here we have three way ANOVA, because n way ANOVA, obviously by n equal to 3, because there are three categorical independent variables. We can also use this model to study the interaction. For example, interaction means nitrogen may perform well at 300 liters of water or 250 liters of water if plowing is used. So this interaction effect can also be brought into the study. So that is the advantage of using n-way ANOVA. Now, if the dependent variable is not a metric variable, that means dependent variable is also categorical. Obviously, two question comes: is the independent variable metric variable? Yes, independent variable is a metric variable. Then we have discriminant analysis, classification, and logit-probit analysis. Now let us look at what is discriminant analysis. Discriminant analysis and classification, they are almost similar. Here we have multivariate observations over several populations. So from different populations, I have multivariate observations. And I know that these populations, these data set are coming from different populations. Maybe one population is population of male, another population is of female. I am measuring male height, male weight, weight of persons, height of persons. These I am measuring. Several other things I am measuring for males, one population. In another population, I am measuring the same thing but for females. So I am making all these measurements. Now discriminant analysis will help me to find out that if there is a new individual coming, with the help of these measurements, or if I have the measurement of this a particular individual, I will be able to discriminate, and I will tell that okay, this is from must have been coming from a male population or must have been coming from a female population. That is what discriminant analysis is doing. So based on multivariate observations, we identify a rule. That means we develop a rule with the help of which may be graphic, maybe algebraic, maybe probabilistic, with the help of which we can classify a new incumbent whose category is not known to the particular category. We can do this classification. For example, suppose I have studied a lot of skeletons. I know that some skeletons are coming from male, some skeletons are coming from female. I know their height, weight, head length, arm span, etc. All this data set I have. Now I am digging the earth. I have found a new skeleton. I don't know whether it is male or female, but I have databases of large number of male and large number of female people regarding their what is that called, skeleton. So discriminant analysis will provide with a separation rule, so that I can identify that new skeleton that I have got must be belonging to population P1 or belonging to population P2. This is how we can find it out. That means if I have a random variable X, multivariate random variable, we can find out whether it comes from whether it follows F1X or whether it follows F2X. Now discriminant analysis, for example, this we have, suppose we have a defaulter and a complaint. I am in a bank and many people are coming to me for asking for loan. I am a bank manager. Now I want to decide whether the person shall be a defaulter or a compliant person with respect to loan. So based on this huge data set, I have already a list of defaulters and list of compliant, and I know the values of the different variables, like what type of job they did, what is their age, how where they resided, is there any person who knows him directly in the bank. So all this information I collect, and then I also see that the defaulters have a particular probability distribution and the compliance have another distribution which are not seen. So these type of things we do in discriminant analysis, that we find out a rule with the help of which we can discriminate. And then once we do this, then we go to classification. Classification is an extension of discriminant analysis. It goes beyond the rules. That means rules are given by discriminant analysis, but actually the classification is done under this. That means the application of the rule that discriminant analysis has provided will be utilized for getting the different types of groups by this. For example, here we have an example. This is the income of a large number of people. This is the average balance that they have. This is the age. This is the average credit card expenditure that we have. These are the defaulters and these are the compliants, and this is the individual. He comes with my loan. Now based in this data set, discriminant analysis will give the rule. That is the rule which you can apply. Now what classification will do? Classification will understand collect the information of these four variables from this individual. That okay, you tell me your income, you tell me your average balance, you tell me your average your age and your average credit card expenditure per month or whatever. So this data, and then they will use the discriminating rule to tell whether this person will turn out to be a defaulter or a compliant. So this is the extension which classification does of a discriminant analysis. Lastly of this section comes logit probit analysis. What is logit probit analysis? There is a single dependent variable which is categorical in nature, and the independent variables are generally continuous types, but the model can also adjust itself for independent variables that are nominal or ordinal in nature, but it should be in coded form, not in numeric in the form of characters like male, male, female, not like that, but it should be coded like females, all females coded as 0, all males coded as 1, like that. Both probit and logit analysis helps to give us a linear function of independent variables and fit it with the help of a non-linear function to the dependent variables. So it creates a linear combination of the independent variables, both the techniques, but related to the dependent variable through a non-linear function. So that is what it does. Both the models predict the probability of the values taken by the dependent variable. For example, this is a simple example where this you see x beta naught plus beta 1 x, this is linear, but it is related to y through a non-linear function. For more variables, then this is the situation. Okay. So this is about logit and probit analysis. We have some examples. Difference between logit and probit is when we define the function p. Actually, logit, we assume that the function p, that is the probability function of the variable y, dependent variable, is follows logistic distribution. But in probit, we assume that the distribution function of the dependent variable y is follows normal distribution. The reason for picking up these two distributions is because they are mathematically handy and easily programmable into a package. So that's why these two functions are taken up. The coefficient of logit regression can be interpreted in terms of log odds ratio and has become more popular in medical science and epidemiological studies. However, probit models are more utilized when the handling non-constant error variance and is more popular in econometrics for heteroscedastic probability models. For example, purchase of a car. Example, we have purchase of a car, decision either yes or no. So that is the dependent variable which is categorical in nature. But the probability distribution of the dependent variable will be related to a non-linear function with age, income, and distance from home. Okay, so we go back to this. We have the last leg of this. So no, if the independent variables are not metric, that means one dependent variable, but independent variables are not metric, then we have classification once again. Here also we can do classification, but classification already we had studied earlier. So this with this we come to an end of the different techniques of multivariate analysis. We have taken an overview and we have tried to understand why these different types of multivariate tools can be utilized. We did not go into the computational details or the deductions of these different techniques, but we have taken an overview so that we can understand what are the purpose of the different multivariate statistical techniques which have very high funder names. So this I think will be helpful for all beginners of multivariate data analysis. Thank you for watching this video.